In this video, we'll be looking at properties of the natural logarithm function. The natural logarithm function is shown this way: f of x equals ln x. And all that means is that our logarithm has a base of e. Now, e is approximately 2.71828, but whenever you see ln, that just means that you have a logarithm with a base of e. So first, let's look at the graph of this function. To do that, it's easiest if we make an xy chart. So f of x is the same as y, and then ln x can be written as e to the y equals x. Now all we're using is the property that y equals log base b of x can be written as b raised to the y equals x. So our base raised to whatever the logarithm is equal to. So we have a base of e, and that's raised to the y, and that equals x. So we'll be looking at the graph of this. Now it's easiest if we let y be the independent variable and then figure out what the x values are for our xy chart. So let's let y equal -1 and then 0, 1, and then 2, just so we can have a little bit of accuracy. Now I'm going to use my calculator to give us the values for this. If we take e, which is second ln, and raise that to the -1 power, we get 0.3679. Let me just write that as 0.37. And then anything raised to the 0 power is 1. And then when I take e to the first power, that's 2.718. So I'll just write that as 2.7. And then e to the second power is about 7.4. So the graph then when x is about 0.4, y is -1. When x is 1, y is 0. When x is 2.7, y is 1. And when x is 7.4, y is 2. So my graph looks something like this for the logarithm function. And we can see that it's asymptotic to the y-axis. So my domain is just from 0 to infinity. I can't have an x value that's equal to 0 because e is a constant greater than 1, and raising that to any power is going to give me a number that's greater than 0. My range is all real numbers. We can see that the graph is continuous, that it is always increasing, and that it is concave down. So it looks basically like any logarithm graph. Now, some of the properties of our natural logarithm function, we need to know these. The ln of 1 is 0, and if you want to think about that as e raised to the 0 power equals 1, that'll help you remember. The ln of a product is equal to the sum of the individual ln of each of these factors. So when you multiply in your argument, then you can separate that into two separate natural logarithms by adding the ln's of each of those factors. The ln of a quotient is equal to the difference of the ln's, and the ln of a power, this is just the rule that says we can take this exponent and bring it out in front of the logarithm. So the n is out in front and multiplied by the ln of a.